Alright, good afternoon, students. Today we are covering percent yield notes. And this is your number 11 notes on February the 10th, 2020. Okay? The first question is, to make a double bacon cheeseburger, 1 hamburger bun is necessary, top and bottom included, 2 hamburger patties, 2 slices of cheese, and 4 strips of bacon. Right? What is the recipe in the form of an equation? Okay, the recipe is 1 hamburger bun plus 2 hamburger patties, sorry, that's a P, plus 2 cheeses, plus 4 pieces of bacon makes 1 double bacon cheeseburger. Do we have this down? Okay, so this is your equation. The question is, if you start with 10 buns and 24 patties and 16 slices of cheese and 40 strips of bacon, which ingredients will run out first? Alright, so let's look at this for a little bit. I have a lot of everything, but which one will run out first?
10 buns.
To make 10 buns, if I have 10 buns, that's 10 sandwiches, right? 24 patties is more than 10 sandwiches, right? It's 12 sandwiches. 16 slices of cheese. How many slices of cheese get on per sandwich?
1.
2. Right, for this one. Well, we
Oh, yeah,
like
yeah.
our hamburgers cheesy, so am I gonna make less?
Yeah.
Yeah, so my cheese is my limiting reagent, or that's the one I run out first. How many double bacon cheeseburgers can you make? Well, how much cheese do I have?
16.
16. How much cheese do I need per sandwich?
2.
2.
2. So 16 divided by 2 is
8.
8. So 8 double bacon cheeseburgers. As you're preparing the double bacon cheeseburger, 2 burgers fall on the ground and your dog licks them. You can't serve them to your friends now. And they saw it. You really can't serve it now, right? How many burgers do you end up making? I'm moving it up.
8.
I had 8, but 2
6.
are ruined.
6.
I have 6. 6 double bacon cheeseburgers, right? What percentage is that out of your total?
3/4. 75.
75%, right? Because I make 6 out of originally, what was my potential?
8.
6 out of 8 is 75%, right? So that's the actual, that's the total. So I have, and then I multiplied by 100, so I have a 75% yield. Does that sound realistic?
Mhm.
Okay, very good. Okay, now next, take a highlighter, please. Your favorite color.
Boy.
And actual highlight actual yield. So actual yield is exactly what it says. It's how much is actually being made in the experiment. How much is actually being made in the experiment? What is my theoretical yield, class?
How much is supposed to?
How much it's supposed to made according to stoichiometry calculation, right? So I'm supposed to make 8 sandwiches. How many did I actually make?
6.
6, right? So actual over theoretical, that's your percent yield. So your your percent yield is actual over theoretical times 100. Alright, so here's what you need to know real quick. When percent yield is less than 100%, right? Let's say you should make 8 sandwiches, but you make less. The possible reasons are the reaction was incomplete. The reactants were not pure. Some of the reactants were spilled after the measurement. Some of them were spilled before the measurement, right? Or your sandwiches simply fell on the floor and you couldn't serve them anymore to your guests. And the opposite is true when the percent yield is more than 100%. So you created more than was expected, the product could be contaminated. Okay? So ideally you get close to your theoretical yield, but you don't quite reach it. Okay? Awesome. Do we have this down? Can I move the page? Alright? Alright, let's look at this next problem. Let's do some practice. I have silver nitrate. Aluminum chloride makes silver chloride and aluminum nitrate. Right? What kind of reaction is this, class?
Double replacement.
Double replacement. That's right. Good. This is just a little side note. Is double replacement a redox reaction, yes or no?
No.
No.
No. Very good. Alright. So the duty here is to calculate the, what do they want us to do? Calculate the theoretical yield, right, in grams of silver chloride. Alright, we can do that. We are now experts. That can be prepared from 200 grams of aluminum chloride. So I want silver chloride, but what they're giving me is aluminum chloride, right? Alright, and I have more than sufficient silver nitrate. So the first thing you need to see is you need to, what is given, turn everything into moles. What is given in this equation, class?
Aluminum chloride.
What is given to us? Look at the red box.
Aluminum chloride.
Aluminum chloride. And I need to change it into what? Moles, right? I don't know how many moles. I can write down X. Moles of AlCl3. The moles of AlCl3, I'm going to change into my unknown right here. So into moles of AgCl. And then because I want my final solution in grams, what do I need to do? I need to change it into grams of AgCl. That's it. So you have a 1, 2, 3, 4-step equation, except you are already in grams, so you're doing fine. Alright, so now let's see. I have 200 grams of AlCl3, so that is 200. In this balanced equation, I only have 1 mole. This is in grams. I want X grams of this, and I have 3 moles here. So in order to change it, from mole to mole, let me show you a little nifty trick. This is what you can do. Let me know when you're ready. Are you ready?
Mm-hmm.
Okay, I need to change this into moles, right? It's in grams right now, so let's change it into moles. AlCl3, I have 200 grams. 1 gram of AlCl3, 1 mole of AlCl3 makes how many grams? What does it say here?
133.33.
Yes, ma'am. 133.341 grams. Okay, so I was here, right? If I cancel my grams, what unit am I in now?
Moles.
Moles of AlCl3. Is this what I have here, my second step?
Mm-hmm.
Alright, so can I check this off?
Mm-hmm.
So now, how do I go from moles of AlCl3 to moles of AgCl? Look at the ratio.
Cross multiply.
Yeah. So you put 1 mole of AlCl3 on the bottom, and 1 mole of AlCl3 has how many moles of AgCl?
3.
Mm-hmm. So if I cancel my moles now, what am I in? Moles of what?
AgCl.
AgCl. Is this right here?
Yeah.
So am I almost done here?
Mm-hmm.
Alright, so now to go from moles of AgCl to grams of AgCl3, what do I need to do?
Go to gram.
So, and you find that right here, right? So you can say, okay, 1 mole of AgCl is how many grams, class?
143.
There you go, 143.321 grams, right? Of AgCl3. So far, so good, class? What can I cancel?
Grams.
Moles, and what stays is grams. I stated grams of AlCl3. Is that what I want as my final product?
Yeah.
Yeah, so can I check this off?
Mm-hmm.
Okay, excellent. Okay, so let's write down real quick. Remember, that's our step 3. How do I write this down? Well, it's 200 times 1 times 3 times 143.321.
You can't see.
You can't see? Sorry. Is that better? This is what it looks like in the calculator, divided by 133.341 times 1 times 1. So far, so good? Alright, yes, my ones, cancel. And then, pull out your calculator and let me know what I get. What do I get, class?
644.907.
44 point something, right?
907.
AgCl. This is my theoretical yield. Alright, can you stop the video? Thank you, ma'am.
Oops.